Hi, welcome everyone, and thank you Will for the introduction. In today's webinar, we'll be talking about collaborative data management and have a little bit introduction to a new library we recently added to our AIM software. My name is Haraldur Haraldsson, and I'm an optimization specialist at AIMS. In today's agenda, we will start by taking a look at what drove us to creating the collaborative data management library by reviewing some obstacles we had in data management. Then we'll move over to discussing about what we want to achieve and what was our drive creating the collaborative data management library. Then we'll take a little bit further look into the library itself and look at how it should be initially set up and what its main procedures and actions are. And then we'll end on a demo showing the functionalities of the collaborative data management library by demoing a multi-user application where we have two sessions and we can see the data changes coming from both sessions. So let me introduce Mr. Yellow and Mrs. Green. Mr. Yellow and Mrs. Green, they work together on a single centralized data set. So usually they open their computers, open their applications and pull data from that central data set. Whether it's the same time or different order, what they do is they take a snapshot from the data set and pull to their application. They both start working on a data set making some changes. As you can see, Mr. Yellow makes changes on the first partition while Mrs. Green does changes to the second partition. When Mr. Yellow is done, he will commit his changes to the central data set. And as you can see, the central data set now has a complete snapshot image of Mr. Yellow's changes. At the same time, Mrs. Green is working on her own changes, and when she is done, she commits her complete snapshot, and as you can see, she overwrites Mr. Green's changes. This, of course, causes a lot of trouble in when big teams are collaborating over the same library. We have before seen clients attempt to create a data listening applications and additions, as well as collaboration tools, but most of them have been proven to be hard to maintain and cause them trouble in deployment. So what we decided then was to create an AIMS collaborative data management library or addition. We call it CDM. So that's a part to our software, our technology, to easily integrate into almost any application, and rather than using multiple codes from individual developers, we now all have a centralized technology that will fit our software. So what we want to achieve above all was to have a version control for a multi-dimensional data. That means that each user would be able to read from the dataset and commit changes he make to the central database in a new version. That allows us to manage our data and keep a historic record of all of the versions, so we can reverse, go back in time and pull old versions of the data. Another thing we want to make it do was to work with a centralized data repository. So far, they've been proving very successful with SQLite and Postgres, and later I will show it with the function of SQLite. And we make it all happen by using a runtime library in our AIMS model. So when we open our model, we start the runtime library, so there is an active connection and listening to all of the data changes, and the communication with the central data repository is always active. The controls we want to include as well was that we want to be able to commit and pull sparse data. So we don't always want to be sending complete snapshot of our dataset, but by saving both bandwidth and unnecessary process power, we just want to commit only the bare changes we do. We also want to have the ability to check the data snapshots from particular versions. So as I said, we can go back in time, take a look at a current situation at some version in the data. Also, we want to be able to create different branches from our data set. So let's say, for example, we have two people on the team want to explore different scenarios or different periods in planning. Then they can create a new branch from the data set and work on that data without having to affect the main data branch or main data set. That branch is not very useful unless we can then also take a snapshot of that branch and check the whole data and compare. So we also have the ability to pull a complete branch from our data repository and take a look at it. And that also includes switching between different branches to take a look at how the data looks. To be able to have it more user-friendly, we also want to include some automation. So the AIM CDM library also includes an automatic commit of data changes to the central data repository, and also automatic pooling of data when other users have committed new data to the centralized server. So that means if we have two people working at the same time, one person will make any changes and commit to the server. They can be automatically pooled by all other users that are working on the data at the same time. And then we have also some callback procedures. So we can overwrite, for example, local data change actions. We can remote commit notification. So instead of pulling data automatically, we get a notification if a different user commits new data, so we can decide if we want to pull that fresh data or not. And then we can set information about the data set, about the author, or if there are any comments with the new data. So how will that new CDM library work in the same scenario for Mr. Green and Mr. Yellow and Mrs. Green? As before, they would again pull data from the central data repository. Mr. Green makes his changes, and when he does, he will push them back to the data repository, and Mrs. Green would automatically pull his changes to her active session. Then Mrs. Green will make her changes and then immediately push them back to the server. So now the central data repository has information about both of their changes. And if Mr. Yellow is still on, he will get his data sent. He will get the data changes from Mrs. Green pushed to his session as well. So now that I've introduced to you the main idea of our CDM library, I want to dive a little bit more into the library component itself. Take a look what it has to offer and what we need to make it work. With the AIM's CDM, we have two main components. We have the library itself, that is a library that we add to our AIM's application, and it contains all the needed identifiers, procedures, DLL files, and an annotation. And I will later in my webinar, I will come a little bit. I will tap back into the annotations to introduce what they are. The second main component we need is the AIM's Collaborative Data Management Service. That is a Windows service that runs on the machine that is running the application, and we need that service to communicate the data. Included in the service, we need to have a configuration file called CDM config to configure all of the needed parameters to connect the systems. So it will tell us what database we have, where is our temporary data folder, ports to listen, and etc. I want to take a quick look at what we need to install that service to get those informations out there as well. So to install the AIMS CDM service, we need all the installation files. The installation files currently come in a folder. From that folder, we need to run the command prompt in administrative mode and install the CDM service. Once we've installed the CDM service, we open the services panel in our windows, the one you can see here, and we have to start the service to be able to have the CDM working on the machine. I also recommend to set those specific settings to automatically start if you plan to use the CDM library on a regular basis. The configuration file CDM config that I mentioned before also has some important parameters that have to be set as well. So here you can see an example of the content that is in the file. So we have the port that the CDM service will listen to. We have a type of database, and as you can see, I'm currently using SQLite. And then we have a database connection string. This connection string has to lead to a temporary temporary folder where we will store our temporary data changes. It is important that you make sure that this specific folder is available, because if it does not exist, the service will not work properly. Then we can add username and password to the database if it's needed to connect to it, as well as some inserts and field types. So when adding the CDM library and setting up the service, we have the option to add categories in an annotation. Our CDM library works with different categories that we can assign different identifiers into the categories. So these are data categories like input data, control data, or output data. So that means that when we push or pull data, or if we make any data changes, we do them all on a category level. To set these categories, as I said before, we use annotations. And annotations, we have introduced them before in our prior webinars, but only recently, so many of you might not already know what they are. But the annotations are user-defined attributes that we have added to identifiers and procedures in the model once we add the AIMS CDM library. The annotation that we use currently with the CDM is the CDM category, as you can see here. So for each identifier we want to put into a specific category, we have to define the category name, and we have to make sure that we only put in the string directly. We cannot use identifiers to assign the annotations. Later on in our setup, we will then use the information about the different categories to choose if we choose which data we want to pull or push or retrieve snapshots of. I mentioned before that our AIMS CDM library communicates only through sparse data, meaning that the library will only send data to the central data repository or pull data from that repository based on if the data has been changed or not. So let's say if you have an identifier with 3 elements, you only make changes to one element, only that one data element point will be sent to the data server. That can cause a little bit of a conflict. So meaning that when you pull data from the data repository, it will overwrite all of your local data that you have. So if you have any local uncommitted data that you have changed and you're pulling a data change for the same element instance, the same data point, that local uncommitted data point will be overwritten. But that also means that if you make local changes that you haven't committed and pull data, and your data point is not included, and that element you make changes to is not included in the pool data, it will not be overwritten because you only pool sparse data. In the future, we are still working on a conflict resolution that we will later in time add as a functionality to our library. To be able to improve the experience while exploring the data, we also included different branches. So meaning that you can create multiple branches in your data set to explore the data, and all of the exploration you do on the different branches is not affecting the master data set. So that means you can have several teams working side by side, exploring different scenarios, and all of their exploration will not affect not the production data or each other explorations either. So this gives a powerful ability to have a collaborative team do simultaneous inspections. The steps we need to take initially in our application to create a CDM application. We need to run a procedure that initially creates the CDM runtime library. We have to create an application database. And that database will be created in our temporary folder we defined in the CDM config file that I showed earlier. We have to run a procedure that creates each of the categories we had defined in the prior mentioned annotations. We enumerate all of the branches that we have, which originally is only the master branch. We have to pull all of those global branches to our model and then set a revision for each category. So meaning on each category level, we have to set a revision. So in AIMS, that procedure would look similar to what we see here to the right. All of the procedures have the prefix CDM, which refers to our CDM library, and all of them are predefined procedures with different input settings, input arguments to be able to run them. And you can see for create category and set the revision, we do them on a category level. So these are steps we need to take every time, only initially when we set up the application database. However, once we've done that and want to reuse our application as we want, we will deploy it. And every time a user opens an application, we have to make sure that he is connected to the CDM application database. Then again, we have to have a startup procedure that runs the connection steps. So first of all, as before, we have to create the runtime library and have the runtime library running. Then instead of what we did before when we created the application database, we now will only need to connect to it. We'll pull all the global branches. We will connect each of the categories we have in our application. Then we'll enumerate the branches to get information about all of the branches that are in the database. And then we check out data snapshot, meaning that we will pull complete data from the data repository to our our application. And again, we have an example of that procedure created in Ames. Again, all of the steps have predefined procedures from our CDM library. The category connections are on a category level, as well as pulling the data snapshot from the data repository. So before we go into the demo, I want to introduce some of the main actions that we have related in our CDM library. So all of our main actions and tools that we use to have the CDM working flawlessly. So first of all, we have the commit. The commit runs a procedure in the CDM library and will commit local data changes to our central data repository. The input arguments we need for the commit is what category we want to commit data from, to which database, and on which branch we're working. So that means we can commit different categories. Usually are working with the same database, but we can also switch between databases. And then, of course, we have to say define which branch we are committing the data changes to. Another step we have is a rollback step. A rollback step allows us to roll back rollback on all uncommitted local data changes. So meaning that we don't take advantage of the automatic function of committing data. So that means if we make any changes and we want to roll back to the previous version we pulled, we can just roll back and get a complete data set again. Our next commonly used action is the pull. So the pull action also works behind as a predefined procedure, and the pull statement will pull data from the data repository that has been committed by other users. In that case, we only have to define which data category we want to pull the data from, and we will pull data and put it in our and we will pull in the data into our local session. And this statement works over all of the branches, so we basically commit all data, pull all data changes that have been committed since we last pulled our data session. The checkout statement allows us to load a complete data set, a data snapshot from the data repository. And when we run that statement, we have to define which category we're running and which branch we want to pull from. So as I mentioned earlier in the webinar, we are able to switch between branches based on which branch we have selected and which data category we're working on. We can pull a complete snapshot of the data. When working with the data revisions in the CDM library, we also have multiple multiple actions we can pull from the data repository, as well as work with it directly. So the first is that, as mentioned before, we can create branches. The create branch statement will ask you to define the name of a new branch. It will ask you if you want to put any comments to the branch. So if you want to put any purpose, if you have any tags that you want to add with the branch, you can do that as well. You have to have database selected. You have to have selected from which master revision you wanna create a branch from, and from which branch as well. Information sent with creating a new branch is as well the author. Another revision related action is to check out all categories. That statement allows you to pull a complete data snapshot for all branches and all categories. So basically it will get you up to date with the current data repository image. That same action can be done on a particular revision level. So then you're not only pulling just the latest revision, but you can actually define which specific revision of data you want to pull. So this is a feature that allows you to go back and look into an historic image of the data changes. And that is also a very convenient function if any mistakes are done or issues are related with any of the changes that have been made in the with the data repository. Then the final three is that you can revert all of your categories to a specific revision. So basically rolling back on the data changes. And then again, you can pull all categories. So you can pull all changes. You can pull data changes from all of the categories that are on your central data repository for a selected branch. And then the final one is that we can retrieve specific revision from our central data repository. So now I've introduced our idea about the AIM CDM library, as well as introduced the main components of the library itself. So at this point, I want to take you to our AIMS application and show you the functionality of the AIMS CDM library. So let's start with the AIMS application. As you can see, we have a big application. It is a machine scheduling application that we've created. And I want to start by showing you some of the procedures I've already introduced. So let's start. We can see I've added the CDM library. I've set it all up and I've tested it, so it's working. And let's take a look at the create application procedure. I've already showed you a snapshot, but here you can see it in live action. Another one that we have is the update application. Every time we want to connect to the database, we run this application and connect to it. This one as well. So with that all being done, we will now go to our model. So here you can see I'm running it currently only locally. So we have here our three machines that we want to schedule, and we have all of the jobs that we want to schedule. We have a collaborative data management window that gives us an overview of our central data repository. So if you take a closer look at it, we can see we have two categories. We have input controls, which is control data, and then we also have just input data. And currently we only have a master branch. So in this window here, we can see we can select between the two branches, between the two categories based on whether we want to use them to pull or push data to our application or to the local repository. And here we have all of the action. If we want to commit, if we want to roll back, pull or check out. This is all on the category revision. And on the data repository revision history, we can create branch, check out the branch, check out to a specific revision, revert to revision, pull all categories, and retrieve the revision. So basically all of the steps I introduced earlier. More information we have is that we have a specific revision number for the master branch. We have a parent revision and a number of changes. Also, we have the committed time, author, and if we have any comment with our commit. If we take a look at the category handling, we can see our control functions that we can set automatic commit and automatic pull of data. So let's see how it looks. Currently, you can see I have set the auto commit on. So going back to our main page, and let's assume I make 2 changes by selecting a manually specified scheduling for these 2 jobs. Going back to the collaborative data management window, I can now see that those 2 changes, number 18 and 19, which I just made, were both automatically committed to my central data repository. Well, if you're doing a lot of changes, you will have a lot of revisions. So for the input data, let's remove the auto commit. And let's go back to our main page. Let's revert part of the data and change some other data as well. Going back to our management window, and we can see none of the changes have been made because we didn't have the input data set to auto commit. So by having the input data selected, pressing commit, we will commit those data, and now you can see number 20 data made by me during the webinar, and we can see we now had 3 changes pushed to the central data repository. So this is all done on a single session. On another machine, I have a different session set up, pretending to be a colleague called Paul. He has the same application connected to the same database. And let's now have Paul make certain changes to our application. Just to be able to demo it more properly, I'm showing you just 2 pages from a web UI. It's still the same application, so this is my session, and now I'm going to have Paul make changes. So I'm going to have Paul revert the manually specific for job 8. So I pushed it on my other session, and you can immediately see the data was changed for job number 8. In my data management window, I can now see that the change number 21 made by Paul because of the demo, I can now see the information has been pushed back to my session. So now I'm going to have Paul make changes without manually pushing them to the data repository. So I'm doing that now. I made numerous changes as Paul. and now I committed them all at once. And as you can see, the data has been manually specified in my application. And if I retrieve the revisions from the repository, I can see he made 6 changes on the master branch number 21. The final feature I want to show you is that I want to have Paul create a new branch for the data repository. So he will create a new branch called the demo branch, and he'll put in a comment. And now you can see that in Paul's revision, he has created a completely new branch and sent to our data repository. So if we would like to review that branch that Paul just created, we simply connect to it again, and we can see here now we have a new demo branch. And what we can do is that we can check out the branch he just created. Oh, where is it? Yep, so now we can see that the demo branch has been included in our current central data repository. So now we can take a look back into our data and see the changes Paul did when he was exploring his own separate branch. Now, this short demo concludes our today's webinar. Before we end, I want to make an announcement of our next webinar in this in our webinar series, and that will be on solving mixed integer nonlinear programming problems, and will be presented by my colleague Marcel Hunting. That webinar will be on June 15th, 2016. Depending on which time zone you are, we'll be showing it at 5 p.m. Central Europe, 11 a.m. On the East Coast US, and 11 a.m. and 11 a.m. Pacific time.